All right, hello. After a great round of talks, I'd like to welcome everyone to our live Q&A session. A reminder to the audience that you can continue to ask questions using that Zoom webinar Q&A box. We'll get through as many as we can through this session, so please keep them coming. My name is Liane Praza. I'm a software engineer, and I've been at Meta for about 5 years. I'll be hosting our Q&A today. I'd like to start by asking our speakers to do a really quick reintroduction of themselves. Let's go ahead and start with Tina.
Hello, everyone. I'm Tina. I've been in Meta for almost 7 years. Nice to meet you guys.
Great. Let's move on to Sherry.
Hi, everyone. This is Sherry. I've been in Meta for more than 5 years.
Cool. Audrey.
Hi, I'm Audrey. I'm a part-time engineer at Meta. I've been here for 2 years, as well as a third-year grad student at UC Berkeley.
Wonderful. Thanks, Audrey. How about Paul?
Hi, I'm Paul. I'm a principal in the Office of the CISO at Amazon Web Services. I've been there about 5.5 years.
Great. Ramon.
Hey, everyone. I'm Ramon, systems engineer at Google for the last 9 years.
Rahul.
Hey, I'm Rahul. I'm a senior software engineer at LinkedIn, and I've been here for about 3.5 years.
And last but definitely not least, Wency.
Hi, everyone. I've joined LinkedIn for almost a year and currently in the TFAS team.
Perfect. So I'm going to dive right into those questions then. One of the things that I loved is that empowering builder and developer teams by delegating ownership was a theme through so many of your talks. It's a powerful technique when solving systems problems at scale. So Tina and Sherry, let's start the conversation with you. Federating out efficiency work and empowering teams to deal with efficiency is difficult. Can you elaborate a bit on finding owners and annotating the ownership of those call stacks you dealt with?
Yes, I can take that. So we start from large endpoints. Then we look at call stacks within those endpoints. We don't have automation in identify those places where ownership change, but we rely on domain experts' help, and they identify the places where ownership should transfer from, say, the endpoint owner to the feature owner. And in terms of annotating the ownership of call stacks, we create wrapper functions and associate on-calls to those wrapper functions. For example, if we identify the ownership should change in a call stack where function A calls into function B, we then create a wrapper function C between A and B. Function C takes on-call and function B as input, so we can annotate ownership on function C to represent the ownership change of function A calling into B. And the ownership is not marked on function A or B directly because depends on use cases, function A or B's cost might belong to different teams.
Yeah, really interesting. So a quick follow-up. So what's the biggest cultural shift you observed when federating out that efficiency responsibility?
Sure, I can take that one. So that's a great question. Basically, we did observe the big efficiency cultural shift on the product side. Previously, as we mentioned in the presentation, only the central service demand team cares about the efficiency. We literally back in product team to fix the regression. At that time, product team only cares about the business value since they are not held accountable for the infra cost. After DEP and the federated model get rolled out, and the product team are held accountable to their overall infra cost so that they start to proactively look for their resource consumption and consult us for efficiency suggestion. We've seen a 5x efficiency win gets landed across the product and the infra side. This does help us scale. Yeah, on the demand efficiency side.
Yeah, that's actually a pretty big efficiency win at the scales that we have. Very cool. Audrey, let's go to you next. So congratulations first on your best industry paper award at VLDB. Yeah, so the layered approach that you described to handle the read transaction on a TAO was really interesting to only have to pay overhead on those workloads that really need it. How can that layered approach be used for stronger guarantees on other systems? How can you extend it to other systems?
Yeah, definitely happy to take that question. So the layer approach we have for ensuring stronger guarantees basically have these guarantees in a separate layer that allows us to retain the system's reliability and efficiency while not affecting its availability, durability, and replication processes. And as such, we're able to make minimal changes to very mature system infrastructure, and importantly, also isolate the costs of providing strong guarantees so that only applications that need them need to incur the resulting performance and storage overhead costs. And this strategy is effective both as a way to retroactively optimize for strong guarantees on an existing system, as well as a way to provide these default guarantees. And we found success here at Meta in using it to provide atomic visibility, failure atomicity, as well as read your write consistency. We believe this approach is effective for large-scale systems in which you do need these strong guarantees for a small subset of your applications, but don't want to affect the overall workload that doesn't need these guarantees.
Yeah, it's a very much a really cool approach. Let's see, Paul, let's return back to that idea of empowering builders. So security is one of those that's rapidly evolving and it's specialized and it benefits from a lot of domain knowledge, right? But as Ramon also mentioned, security and privacy incidents are something we all want to avoid. So how should security think about empowering builders in an organization?
So the way we think about it is that the job of the security organization is to help people ship securely. And the way that we want to approach that is that we want to give the builders who are closest to the business problem they're solving, so in our case, AWS service teams, we want to give them the information that allows them to make informed decisions. And we also want to build automation which gives them feedback when they're in the moment of building, so they don't want to have to wait until a security review to get fast feedback that they are heading in the right direction. And we kind of then support that by training people who are embedded in service teams. So we have a program called Guardians. So we take a software development engineer and we teach them how to think about security. And they're our advocate in the service teams. And they also understand how to go through the security review process. And we found that giving people information to make informed decisions allows them to much more quickly get features in the hands of customers. So we're kind of trusting the smart people that we have in our organization, giving them guidance in the security domain, and then providing automation and measurement so that they know that they're doing the right things. And we still verify this because we own the security of AWS itself, but we want to help people get to shipping more quickly and maintaining that security bar.
Nice. Yeah, because that educating more people certainly helps. And as a developer, I definitely want to own the security of my own systems too. All right, Ramon, I'm actually one of Meta's site level incident managers, so I really appreciated your view into the Google incident management process. I wanted to ask about those heuristics you mentioned for how teams decide if something rises to the level of being an incident. Can you elaborate a bit more on how teams make that decision themselves?
So for deciding what class of outage or what class of incident makes it to an incident that you need to respond in the way that I was explaining, like coordinated and so on, you need to empower the teams to understand what is the business impact they have, right? So for example, in my team, we are the identity and authentication team. We had a bunch of outages last weeks, right? They were not user visible, but outages at the end. And then the impact you have, for example, for YouTube, that is a video service, will be measured in things like watch hours that they are affected, the time of buffering that people is seeing in their applications. But if you are serving, for example, an application that is a transactional service like Gmail, you are going to be interested into other metrics, right? Like the amount of email that you are being delivering per second and so on, right? And then obviously the size of the services is not the same. So when you have service like Gmail with billions of users or something that is more small that you are launching, right? The thresholds, they are not there. So each of the teams, they should be empowered to determine ahead of time, like what would be guides for saying like, look, this is like a huge outage, like because you're affecting like 10% of your user base or whatever. And then centrally, you need to provide tooling for example, the alerts to be annotated. Like when you receive an alert, like your system is not meeting the SLO, just indicate like, for example, these are the number of users that you are affecting and so on.
Nice. So understanding the business impact and having those metrics seems pretty important in this case. Cool. Rahul and Wensi, so you guys thought pretty deeply about adoption, which can be a thorny problem with big infrastructure changes for sure. So what's the biggest challenge that you encountered while onboarding all LinkedIn developers to infrastructure as code?
Yeah, so I can take that. So the biggest challenge, I think the challenge that we encountered in getting IAC adopted are twofold. So one is the engineering challenge that we get as soon as a lot of users come on board a platform. A lot of developers use that. And the second challenge is also the cultural shift that we have to do and help people realize that this is the better way of doing this by getting it adopted to a few organic users. So for this, we had to design a multi-quarter strategy and also plan various phases in it. So for example, one of the first phases was how we will develop Terraform providers for all the core services that exist at LinkedIn. So that if, let's say, people and developers have started using it in, for example, their compute, networking, and storage components, which they interact most frequently with in day-to-day operations. So that will give us more organic adoption. Second part was also like educating all the developers in using IC and Terraform. And then in terms of engineering challenge, I'll mention one of that. It was importing everything that already exists right now to IC and Terraform. And for that, we are planning on building an importer tool, which will import all the resources to IC with minimum friction for the users.
Nice. Yeah, that tooling strategy is often really important and helps people onboard to the new system. A quick follow-up for Wency. In part of your talks, people were asking about if you could clarify a bit about what you meant by fabrics.
Yeah, sure. So fabrics in LinkedIn is like a concept of a stacked data center or an environment that includes all of your services and infrastructure that for us is like running the LinkedIn.com.
Okay. And I think another follow-up here, lots of good questions for LinkedIn. So, if we're to build a new service that kind of runs on one virtual instance, could you walk us through the architecture as the instance is kind of requested, approved, created, and changed, is how this works with your Terraform as a service?
Yeah, so is it about, just to clarify, is it about how like we deploy services on the Terraform platform?
Yeah, so how you kind of the life cycle of the service from when it actually is requested to all through its deployment.
Yeah, I can give a brief overview. So right now, the TFAS platform that we have, it supports like two modes of operation. So one of them is managed mode, which deals with all the services that we can provision at LinkedIn. And we are focused on building Terraform providers for that. Also, there's a second unmanaged mode, which deals with a bootstrap scenario. For example, the services which are not dependent on LinkedIn frameworks. For example, let's say you want to provision something, virtual machine, or let's say a storage account in Microsoft Azure, then you can use that mode to do all that. So this whole flow is really self-service. So there's nothing which is like dependent on our team, and users have to request that we want to create this flow. So you just have to create a workspace. So in our TFAS terminology, we have a workspace concept, which houses all your infrastructure that you want to have for various environments, for staging, for production, and etc. So you just define your Terraform config files inside those workspaces, and we have few simple commands which you just run them, and all the provision will be will make sure that all the infrastructure is already set up and ready for you. So this is how simple this process is.
Nice. Yeah, simplicity for as we have lots of engineers in our companies that work at large scale is really important. Not everybody wants to be an expert in all of our infrastructure, even though we love building it. Let's move to Ramon. Quick question here is, I don't know if you're an expert in this, but I'd love to hear if you are. Is distributed tracing used for observability? If so, then which framework? And do you understand the effectiveness of that? Can you talk a bit more about distributed tracing?
Yeah, so I think it's well known that at Google we use Dapper, for example, for distributed tracing. So all the services they collect traces for the whole call tree of your request. So if you have a microservice mesh, you will have APIs that they cover different subtrees of that microservice mesh, and you would be able to collect distributed traces of that. They are super useful for debugging, by the way, right? The major problem that I see, or the major problem, the thing where I have fought hardly while responding to outages has been like whenever you have a very high QPS or high request per second service, and only a small fraction of your system is broken or is like serving requests that they are like serving badly to the users, finding them, right? So like it's nice, right? But you need to get used to like navigating them, understanding what they are, like understanding, for example, flame graphs and all that things, right? I would strongly recommend people to look at, for example, Open Telemetry if you're running in Kubernetes or other frameworks, right? Because that's really wonderful.
Yeah, open telemetry evolving as a standard is a pretty cool thing in the infrastructure and observability space for sure. Audrey, let me go to you. So why is the limited retention window sufficient to guarantee atomic visibility?
Happy to take that. So as I mentioned, the vast majority of read requests to Tau and the data they're fetching are already atomically visible by default, either because that data hasn't been updated by write transaction, or it's already up to date enough that we don't need to do any additional checking. It's just for the cases where you might read one version that's more up to date and another version that you read from cache hasn't been updated yet. That's when you can see a violation. So, and these cases usually happen when Tau's replication hasn't caught up with the current local region you're fetching data from. And since Tau's replication lag is usually bounded within 60 seconds, we just need to cover for these cases. So as I mentioned, we leverage the refill library, which is a metadata buffer storing the past history of writes. And this spans for 3 minutes. So we're able to guarantee that within this window, most of that data has already been updated. And in the very rare cases when there's maybe like a data center outage or something that causes the retention, the data you need to be longer than 3 minutes in the past, we have an optimization we describe in the paper in which we don't go fetch the newest version, but we fetch an older version that is already available in your local region. And this is sufficient to fulfill atomic visibility.
Nice. So let's expand on that a little bit. We have a question coming in from the audience about a student who's learning about concurrency issues, critical sections, locking. So let's put it out to the larger group. So how often have you seen issues that caused by deadlock come up in your systems? Anybody want to take a swing at that?
Sure, I can describe.
Yeah, why don't we start with you, Audrey, and then we'll move on to the next person. Cool.
Yeah. Happy to. So we actually have we've explored this issue in detail through Tau Bench, which is the benchmarking framework I mentioned. And we actually have some of this data, including contention and deadlock errors, now available, publicly available through our benchmark. But we found it is definitely a significant issue for Tau engineers. And a lot of these cases in which we have deadlock, which lead to contention errors, are actually intentional from the application side. So an example of this is like application might want to look at like video time slices, and it needs these edges to be created in the social graph. And to make sure it happens in a timely manner, it will send redundant requests, knowing that the system will allow only one of these requests to be fulfilled. So this is an example of how the applications are knowing that the system is providing stronger guarantees and leveraging those guarantees in a way that it can safely ignore those deadlock errors. But in other cases, that's not possible, and those need to be dealt with through collaborations between the system engineers and application developers.
Interesting. Anybody else want to comment here? Got a lot of experts.
I was going to say that I had a couple of instances of this in production, like in the last weeks, right? And there is so when you have a large scale system, right, the manifestation of these things is very weird, right? And likely unrelated to what you think, like it's not a contention or a deadlock is not what you think like upfront, right? So for example, I had a service that was like the autoscaler was just getting up in memory and in like replications of instances and so on. And it was because there was a deadlock and contention. So each of the tasks like we had in the cluster couldn't respond as many requests as possible, right? So we thought it was demand driven or whatever, but it was actually contention. The other one that we saw very recently that was interesting was with Java services. So with Java services, the JVM will have this garbage collection that at some point might stop the world for doing stuff when one of the generations is full and so on. And that has the effect of like contending with the actual application that is doing threads and so on. So I think going back to the open telemetry that we discussed before, like collecting metrics about the healthiness of your threading model. If you have like a threading model, or you have like an asynchronous, like call queue and callback stack, right? And the JVM, if you run Java, for example, I think it's very interesting for debugging this real time, right? Because you want to have these metrics beforehand, not after the fact.
Yeah, definitely implementing a strategy for debugging a deadlock live. If you don't have instrumentation is definitely tricky in distributed systems. Anybody else have any thoughts on this question? Okay, we'll move on to the next question then. How about we go to Paul? Let's talk about culture and security and the combination with tooling. I love the systems problem end to end. So you know, kind of what role does culture play, and how do you support that with tooling and technology?
There's a few different ways of looking at this. Looking at it from the perspective of the security organization, seeing that our role is to help people make good decisions. We also want people to come to us for help. So there is a sort of trope about security being the Department of No, and we very much want security to be the Department of Yes, but. We want to empower the service teams to actually get their services and features in the hands of customers. So we help them understand what they need to do to actually achieve that. And that means that we want to be approachable. We want people to know that if they need guidance around a particular architecture, or if there's a particular problem they're trying to solve, they can come to us for assistance. And that's why we have this culture of yes, but. And then there's also the culture of ownership. I think we talked about kind of distributed systems and decision-making autonomy. We want the people who build and run the systems to take ownership of the security decisions with our guidance. And that culture of ownership really factors into how you can get to good outcomes. And then to support the human aspect, because humans are building these systems and humans are doing security reviews and humans are supporting the builders. We want to build tools that take the undifferentiated heavy lifting away from our builders. So if there's something that's just a checkbox, or we know that we can pass some code, or we can check a configuration, and we know that that state has to be true, we don't necessarily want a human to go and validate that. So that's how we prioritize the next most important thing to automate. Because if we can programmatically give feedback to the builder at the right part of the software development lifecycle, that's our way of demonstrating that we're here to help, and we're getting out of the way and allowing them to make the decisions about their systems that are important to how they solve their business problem. So the tooling supports the fast feedback, which reinforces the culture of both ownership and the fact that we're all trying to get to the same outcome, which is awesome features in the hands of our customers.
Nice. Let's talk a little bit more about building with some folks. So I've got a couple questions about building the system. So how about we start with Tina and Sherry? What was your biggest challenge when building, the DEP platform?
Sure. Yeah, that's a good question. I can take that one. So basically, we could think of, like the challenges, like two challenges, like on top of my head. The first one is like the design decision. Like previously, we are kind of trying to trade off, like provide a flexible platform so that they can just implement their own demand and efficiency, like management. Another one is we need to unify the product attribution, unify the cost, so that we have this unified foundation, have this like overall like infra cost kind of like that. So both are good. Like the first one is it's very flexible, and the product team, service team can onboard it immediately. They don't need to change their attribution model, kind of like that. But the downside of that one is basically you have. There are lots of customization, and make that a platform is kind of like a super complicated, but at the same time, it's quite far away from our end goal. basically our end goal is wants to surface the overall cost, like have this ROI comparison kind of like that. So at the end, we kind of like, lean towards this, okay, how about we have a unified product attribution, unified cost, and then we start to let the platform to get on board to DEP. The second challenge we say is like how to persuade the product and service team gets onboarded to DEP platform, because in order to surface that holistic cost, those kind of things, we need lots of product team gets service team gets onboarded. So what we do is we just show incremental value. Like they are not blocked by others. Say, okay, we only show the value after all the other product team or service team on board to DEP. Instead, they can just onboard to DEP and start to use it to manage their own service demand and efficiency. And so that this is kind of one of the strategy we try to persuade them to get on board to DEP.
Nice. I really like the anchoring and what the business problem is. It's always kind of going back to that as your first principle, and your first question, your first answer was really fascinating. So let's see. In terms of building, how about let's go to Rahul and Wency. One of the questions we often all have to ask is, do we build versus buy? That is to say, do we build something in-house? Do we adopt open source? Do we buy something external? So why did you decide to build your own Terraform platform instead of considering Terraform's enterprise solution?
Yeah, sure. I can take this question. So this is actually a really good question. So it's actually happening from the beginning of us taking the initiative of starting to use infrastructure as code, and then we discovered this very popular and open source tool, Terraform, and we know that they have their enterprise solutions called Terraform Cloud. So the reason that we decided to build our in-house Terraform platform is first, like the biggest challenge that we discover is how to integrate Terraform with our LinkedIn ecosystem. So at the time we started to use this, our internal tooling system would not have worked with the Terraform Cloud because our own CI/CD system is very complex and it needs to be re-architected if we are using Terraform Cloud to accommodate all the Terraform use cases. And also to support Terraform Cloud, we need to stand up kind of some proxy in front of Terraform Cloud to talk to our internal downstream services endpoints. And so to get the core functionality out of Terraform Cloud, it didn't actually take us too long to build that in-house. And secondly, there's lots of LinkedIn specific workflows we need on top of Terraform Cloud at the time we started to use IAC to create like a smooth transition to migrate all the services to infrastructure as code. So for example, like what we mentioned in our demo, the import workflow, the drift detection and drift remediation were actually not available yet on Terraform Cloud. So that's why we build our own functionalities. And also, lastly, what I want to highlight is that we have massive scaled and collaboration across over 1,000 teams and thousands of engineers within LinkedIn. So from a cost-effective standpoint, we don't really want to enforce like a different operation flow or force us to structure our IC code just to kind of save the cost we will spend on Terraform Cloud. Yeah, that's what we have.
Makes sense. Thanks, Wency. Okay, I think with this, we'll basically close out this live Q&A session. Thanks again to all of our speakers for their really informative talks, and to everyone for listening in to this Winter Systems at Scale conference.